solve y double prime minus 10y prime plus 26y equals 0. So the first thing we'll do is write down the characteristic or auxiliary equation. So we have y double prime, so we write down m squared, minus 10, and then y prime is just m. And then when there's a y, you don't do anything, so plus 26, and this is equal to 0. So you can try to factor this. If it's too hard to factor, you can use the quadratic equation. So in this case, we'll do that. So this will be our a. So a is 1, b is negative 10, and c is 26. So m is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And then just be careful. Let's see. So b is negative 10, so we already have a negative, so we're going to get 10. Plus or minus. Then we have the square root. B squared is negative 10 squared, so that's 100. Minus 4, and we said a was 1, and c is 26. It's all being divided by 2 times 1, because a is equal to 1. So this is equal to 10 plus or minus the square root of 100. 4 times 26 is 104, and it's all being divided by 2. So this is equal to 10 plus or minus the square root of negative 4. Yeah, 100 minus 104 is negative 4, and it's all being divided by 2. So this is 10 plus or minus 2i, all divided by 2. We can break this up. So m is equal to 10 over 2 plus or minus 2i over 2. So we end up with 5 plus or minus I. So it looks like we have solutions that are complex conjugates. So our solutions are of the form alpha plus or minus beta I. In this case, alpha is equal to 5 and beta is equal to 1. And whenever we have complex conjugate solutions, the general solution has the form c1 e to the alpha x cosine beta x plus c2 e to the alpha x sine beta x. So all we do now is plug everything in. So y is equal to c1 e to the, we said alpha was 5, so e to the 5x. And then cosine, well, beta is 1, so 1 times x is just x, plus c2 e to the 5x, and then sine of x. And that is the final answer. So whenever you have complex conjugate solutions, your solution always takes this form. I hope that made sense.